I think I will slightly start such that we are not losing some time later on, as the program is quite dense. So welcome everybody to this Soilver workshop, which is entitled "On the Knowledge Road Towards the EU Soil Strategy and Law." And this is one of the several workshops that we want to organize. This one is the first one on soil monitoring schemes in several European countries. Ingrid, next slide, please. Some just usual house rules. So please keep your micro on mute and turn off your video, except when you are talking and addressing some questions. First, use the chat, and then we can invite you to express your question to all the participants. Next slide, please. So, yes, I'm speaking on the behalf of the Soilver platform, which is a platform on soil and land research, funding, and exchange. This is a permanent self-funded platform, and we are especially working on two pillars. The first pillar is targeting knowledge development, and so we have launched a pilot call in 2019. And we are thinking of having a full-scale call in the coming year. We also are wanting to have more targeted actions with smaller budgets to really unleash some gaps that we have identified. For now, the topics are related, strongly related, of course, to the EU soil strategy and in phase with the soil health law, which will be proposed by the Commission soon, next year. And so the topics that we have already discussed are risk assessment, policy decision support, such as tools and other guidelines, circular economy topic, the soil and land restoration and monitoring, which is one of today's topic, and contaminants of emerging concerns. The second pillar we are discussing are, of course, to get more exchanges between us, to get more information and be more efficient. We had online pilot workshop on PFAS in 2020, and then several coffee break meetings in 2021. Those coffee breaks, you can find them because they were recorded on our website. So if you are interested by some of the topics, you can just go and go there. We also had a collaboration between the Common Forum Network and the EEA-IONET Working Group Soil Contamination to have a focus on lead contamination. It was at the end of last year. And we also had exchange on the results coming from the 3 pilot projects that were funded at one month ago about. And today we want to exchange on the some of the topics that are discussed within the EU soil expert group. And one of the first topics that is discussed there is the soil monitoring issue. So we wanted to provide some more insights of what's in the countries and how is it working practically. Next slide, please. Yes, so we really want to contribute today together how we can have more exchange and cross-border collaborations, and also what could be the next steps for collaboration. So don't hesitate to contact us. You have the information, the mail address, the website, and we would be happy to share further information with you. Next, yeah, and if you want to join us, it's a self-funded platform such that you can be a member at different level. You can be a full member, being part of the overall discussion and the strategic discussions and decisions. You can be affiliate member for some part of the pillars, either only for funding issue or for exchange issue. You can also experience focused funding by being a third party. And you can also be kind of an explorer to look in the platform how it's working for 1 year before deciding yourself of becoming a integrated full or affiliate member. We have a membership agreement, of course, and there is a contribution to the secretariat fee. And you can find all the information on our website, which is stated there. Next slide, please. So today's program. So first, yeah, what I just did is welcome you to this workshop, which is divided in two parts. The first part is about the European level, I would say, so connecting EU and member states monitoring and use of data, with two presentations, one from Arwin Jones, working at the GRC and in charge of the Lucas campaign. And the second presentation from Claire Chenu, working at INRAE, and she will be talking about the EGP soil project, which is targeting the soil monitoring schemes in Europe, in different European countries. There will be a small session of 5 minutes, question and answer to both of the speakers. And then after, we will be zooming in soil monitoring in some of the countries in relation to the objectives of the soil strategy. So with three case study, I would say, one from France with Antonio Bispo, will talk to us about the RMQS network, the soil quality monitoring network. We will have also the pleasure to hear Fanny van Egman from Wageningen University in Research on the Dutch soil monitoring system. And I will give you some insights on how we deal with monitoring schemes in Wallonia. Afterwards, we will have overall discussion, and we will try to get some key messages to hang over to the soil expert group for their next meeting on soil monitoring. The end of the meeting is foreseen at 12:30. So thank you for joining, and let's go to the first part, which is Arwin, who will present us some European exercise on soil monitoring.
Hello, Esther. Good morning. Can you hear me okay?
Yes.
Great. Thank you very much for the invitation to be part of today's really interesting and highly relevant, as you've outlined. And so I'll just maybe set the scene by describing what we are doing under the Lucas soil activities. I'll just start to share my screen. I'm afraid I can't share my screen while someone else is sharing. So
I've stopped it, Arwin. You can share your screen.
Okay, thanks. Hopefully. Okay. So indeed, I want to just basically run through quite quickly what's going on in relation to the Lucas, the soil module of the Lucas survey for 2022. So as you're aware, our colleagues in the European Statistical Office carry out a regular survey of the EU, specifically looking at how land use and land cover are changing over time. And since 2000...
Wayne, excuse me, do you share your screen? Because we don't see anything.
I thought I was sharing. Sorry, just a moment.
That's what I thought too. It's better to say it now.
Yeah, indeed. Let me...
Yeah, this is perfect. Thank you.
Okay, sorry about that. Okay, the first slide was only the introduction anyway, so it's fine. So indeed, as I said, that since 2009, the GRC has been introducing a soil module into this regular survey, where initially we've been targeting just over 20,000 locations from across the EU. We've had some parallel exercise also in the Western Balkan candidate countries, accession countries, and also in Switzerland. But primarily, it's an EU survey. I think what's important that it's the only harmonized soil data collection program that we have for the EU at the moment. I don't claim that it's perfect, but one of the things that we do is that we carry out a single data collection program that tends to run from around, let's say, April to late September, October, where we have a systematic collection and then analysis of soil characteristics um, for the whole region. It's a project that's been extending in scope, and I'll come back to say a few words on that point in a moment. And we're currently underway. A lot of activity in setting up, I would say, rather than planning, the 2022 survey, and I'll spend most of my time talking about that. Maybe just to flag an interesting development is that the methodology that's been established for the European soil module has actually now been extended to the whole of continental Africa, where it's being used to develop a baseline of soil characteristics for agricultural soils in Africa, and that's a project that's currently running and coordinated by Wageningen University. So obviously we're also moving out of the boundaries of the EU. So in essence, it's a topsoil sample now based on a selection of points from a regular 2-kilometer grid that covers Europe. It's based on a composite sample derived from 5 subsamples, as you can see in the diagram here. We tend to collect from a region around 2 meters around the Lucas point, which is identified by the surveyors from GPS locations and ortho photographs, so they can be consistent that they're returning to the same point. And from these 5 samples, we mix within a bucket and extract about 500 grams. Usually it comes back about a kilo, I have to say. And that then is sent off to analysis. It's rather a simplistic approach because we're not necessarily employing soil surveyors, and our scope is to try to collect as many samples as possible in order to have a good regional perspective on soil characteristics rather than focusing on individual sites per se. So that's the approach that we're adopting. We simply take a V-shaped hole down to a depth of now 30 centimeters, and it can be done very quickly with very simplistic equipment, and there's very little subjectivity from the point of view of the surveyor or the sampler. As I said, it's important to reflect that we every individual parameter is measured in a single laboratory. We don't necessarily have to have a single laboratory doing all the work, but to avoid, let's say, discrepancies within individual parameters being measured by different laboratories, we insist that every parameter, so pH, carbon, for example, is actually measured in a single laboratory. So we have 4 modules within Lucas. So excuse me, my phone's ringing. I'll just put that off. So the first one is what we call a standard sample, where we collect air-dried samples, and the majority of the survey is carried out in this way. We have a module that looks at soil biodiversity, where the soil sample is actually kept as fresh as possible and eventually frozen within, let's say, 48 hours of its collection, so that we can then subject that to, in our case, predominantly genetic assessments, so soil DNA, metagenomics, metabarcoding, and so on. We also have a bulk density module, where we use sampling cores to collect an undisturbed sample, and we then take the dry weight of this to calculate bulk density and some elements of soil moisture. And maybe just to emphasize also that we have a sort of a landscape module where the surveyors are asked to identify in the field certain elements that are relevant to soils. So the presence of crop residues, erosion control features, and even actually certain erosion aspects as well. So in this case, in 2018, we looked for signs of any type of erosion, while in 2022, we're looking just specifically at gully erosion. So all these are basically are analyzed in different laboratories. The residues are then stored at the JRC, so we have an archive that allows people to come here and resample the data, the samples if they need. And then we make the data available through the European Soil Data Center portal. And then, so over the past 9 years or so, we've been able to make an array of uses from these data, starting from simple property maps for physical and chemical attributes to increasingly more sophisticated products such as the microbial biomass and the training of an ESA project to monitor soil carbon by Copernicus systems. So there's a broad and an increasing range of use of these data. So in the planning for 2022, there was quite an intensive discussion within the Commission soil usage community, so the different policy areas that have an interest in soils, generally agriculture, climate and environment, but also other parts as well, to see how the Lucas soil module could increasingly evolve to reflect an increasing demand on soil within the European Green Deal as it was being planned at that time. And as you can see here, just this graphic shows you the real explosion of interest in soils from across the policy community. So what we tried to do in 2022 was to see, well, could we adapt the Lucas module in a way to provide more information for these services, and in particular to try and capture increasingly the multifunctionality of soils that each of these policy areas are trying to address. So the main outcome for the Lucas 2022 survey was that we were asked to at least have as a main target the capacity to provide statistically robust assessments of soil carbon content, stocks eventually, at a NUTS2 level, so at a regional level, and especially for croplands. And so this basically drove the main design of the 2022 survey, which meant that we had to increase our sampling from 22,000 up to 41,000 locations across Europe, so a significant change in scale. And this was consisted of, let's say, a fixed pool of 17,000 points where a location had been visited at least twice the previous two surveys, so at least we maintain, let's say, this core where we have repeated measurements, and then obviously 24,000 new points, predominantly on croplands. And then an interesting development was that these sites were selected based on a prediction for the soil organic carbon content, based on a, let's say, on a model of covariates that would, let's say, try to drive carbon content. So in these new sites, we also were asked to increase our sampling depth from 20 centimeters to 30, so to be compliant with IPCC reporting, so to help member states also to, if they want to, understand carbon stocks for this specific depth, because in the past the 20 centimeters was deemed not to be sufficient. We also increased the number of soil biodiversity sites now to 2,000 from the 1,000 that we did in 2018. Maybe an interesting angle here was that we added a significant number of points within the Alpine regions because it was a region that was underrepresented by Lucas originally because they had a cutoff limit of 1,000 meters for sampling. And we've also tried to target all the capital cities of the EU as well. So to look at soil biodiversity within an urban context. So we have a number of sampling areas in there just to see what's going on. So we carry out the bulk density on measurements on all the bulk density sites. Sorry, 1,000 of bulk density sites that were measured in 2018 on all the new biodiversity sampling sites, and then we have another 2,000 randomly selected sites, predominantly on cropland, because that's the area where we want to look at in terms of maybe trying to get an angle on soil compaction. We also tried to modify our sampling schemes for woodland because we had some inconsistent data coming out of some woodlands because of, I think, the interpretation of how surveyors were dealing with the litter layer. And so now we ask surveyors to actually collect a sample of the litter layer from a cut so that they can more accurately find the surface of the mineral horizon of mineral soil, where we're actually then asked them to carry out the standard Lucas data set. So this is also more in line with what's been expected also, again, from the IPCC and the LULUCF approaches, where countries are being asked to quantify also the carbon content in the litter layer of woodlands. So I think this is a very interesting development. As I said, we've also targeted the Alpine region with a lot more points in here because it was underrepresented as an area. We now have, let's say, over 100 points above 1,500 meters in altitude, even going up to 3,000 meters. Okay, the context was that they had to be easily accessible, so that surveyors didn't have to waste too much time in getting to them. I should point out that the hole in the middle here for Switzerland isn't really a hole because the Swiss Federal Environment Agency is actually carrying out Lucas on their own right for this region. So we have about 150 or 160 points also using the Lucas methodology for Switzerland. And now actually there's an interest in Norway to join the program. I just want to flag, but I think I won't talk much about this because Claire is coming after me. One of the main elements of Lucas is that we really see a need to integrate more with the activities taking place within member states, both in terms of being able to support member states with soil data, but also to have a sort of a one data approach where we can also maximize any reporting, let's say, in a broader sense, of soil condition and soil health with all the available data that we have. And I think that for the next Lucas, which may be in 2026 or something like this, we would like to see this as the first operation of a possible integrated soil monitoring system for the EU, and with EJP Soil and other actors. We're looking to see how we can go about achieving this. I've said that the data are stored here, so there's a lot of interest from researchers coming to analyze additional parameters. So I think I'll stop there, and if there are any questions or comments, I'm here all morning and I'm happy to be part of the workshop.
Thank you, Arwin. If there are some discussion, but maybe we can gather the question after the presentation of Claire, such that we can have an overall view. So maybe Claire, please.
Hello, can you hear me?
Yes, we can hear you.
Okay.
Your screen and it's well shared. So
okay, let me just okay, so good morning, everyone. Sorry, I was a bit late. That was new in advance, but I was a bit late. Okay, so first I would like to say that the developments in Lucas are really impressive. The new ones with additional points and the Alpine region, well, that's great and great for the future. Okay, so my topic today is to tell you how AJP soil activities will support the future EU soil monitoring scheme. And I have prepared this presentation with my colleagues from AJP. AJP Soil is a joint program. It's a co-fund program, as said Arwin, which has as a goal to build a sustainable European integrated research system on agricultural soils and to develop a framework on climate smart, sustainable management of agricultural soils. So what we do in the AJP, well, you see there are 24 countries participating. You see that on the map. And what we do is essentially knowledge development, in particular towards understanding the effect of soil management and its influence on soil health. We also have activities related to knowledge sharing and transfer to strengthen scientific capacities and cooperation. What concerns us today is our activity regarding supporting harmonized European soil information. And we also have activities that are more in a knowledge type of development type of fostering knowledge application that is fostering the uptake of climate smart, sustainable soil management practices. And what we deal with is really multifunctional agricultural soils with objectives of agricultural production, sustainable, preserving, improving the sustainable environment, and climate change adaptation and mitigation. So we are at the intersection of these different zones. In the AJP, so we have different work packages, and one work package covers our activities of supporting harmonized soil information and international reporting, where you see different tasks. For example, one on basic data standardization and harmonization, developing thematic layers, soil baseline, soil modeling, soil indicators, and soil monitoring in the field, and developing innovative methods, high throughput methods to characterize soils. So far this year, so AJP soil began 2 years ago. And in work package 6, there are 3 deliverables that have been issued last year, which I consider are important ones and are very well related with the topic of today and with the development of a European monitoring framework. The first one concerns harmonized procedures for creation of databases and maps. This was a stock take. So we do in the AJP soil, one of our first objectives was to establish the baseline on many topics in Europe. So we performed quite a number of stock takes, and these are essentially stock takes. We issued a second deliverable, also relevant for at the EU scale, on national and European regulations on agricultural soil data sharing and national monitoring activities, and this has led to an agreement on how to share data within AJP and outside. And a third deliverable, which I will present later, that is a proposal of methodological development for the Lucas program in accordance with national soil monitoring programs. So the main topics again covered by this work package 6 are identifying the existing soil data within different countries and develop ways to expose them, share them, exchange them. Defining, calculating, and mapping indicators for soil health, soil threats, and soil-related ecosystem service in close collaboration with GRC and the European Environmental Agency. Identifying soil monitoring issues across AJP soil partners, and again in collaboration with GRC, and contributing to a common ground for the future European soil monitoring system. European Soil Observatory, excuse me. More precisely, in relation to soil monitoring, so we first underwent a collaboration with Lucas, actors to define and identify the additional sampling points in EU countries. So we performed this deliverable 6.3, that is a stock take of soil monitoring networks across our partners. We synthesize it and we prepared the deliverable, and we are now preparing a scientific paper, and we compared data sets, protocols, lab methods, and sampling designs. So this stock take on national soil monitoring systems. So 18 countries out of our 24 countries within our consortium answered. And they described 27 soil monitoring systems. So among our consortium, some countries do not have any soil monitoring system. That's the case for Turkey, that's the case for Portugal. And 5 countries have more than one, as you see on the map. And it is either because there was a wish to have regional soil monitoring systems, or because they can have different purposes. For example, contamination versus agricultural quality, or forest versus agriculture. But in this inventory, you must remember that we really focused on agricultural soils. That's the scope of the AJP soil. So not all countries declared their own forest soil monitoring system. What we did was to compare, so we characterized, well, the colleagues from Work Package 6, and Antonio Bispo was actually the lead of this activity. The different national soil monitoring systems were characterized. For example, what is the main objective? You see that most of them is general soil quality monitoring. What are the investigated land uses? Mainly agriculture, but again, there might be some bias because of our starting points. We work on agricultural soils. Most monitoring systems have a stratified system with representative sites, but still a good share of them have a grid-based sampling design. The area that is collected varies, but in general, it is smaller than 100 square meters. Regarding sampling depths, so there are different strategies, of course, sampling according to horizons. And you have the number of soil monitoring systems that sample to how many horizons, and sampling to fixed depth. And again, we established who was doing what in terms of which depth, how many depths were considered. And we found that only 13, but at least I would say 13 member states are sampling deeper than 30 centimeters. And there are a number that sample for bulk density also. What we did also, and this is still ongoing, as it is explained in the title here, is that we inventoried what were the characterization, the analytical methods being used on the samples taken. And you see, for example, that, well, a lot of them, of course, measure soil carbon, pH in water, and soil texture, but also micro and micronutrients. And it's much more unequal regarding other properties, such as, for example, spectroscopy, infrared spectroscopy. So this is being completed, and we're also comparing the methods being used for these different attributes. Now, also, this stocktake was used to explore the possibilities of harmonization between the different monitoring systems, and especially with Lucas. And you see, for example, examples of answers. So the challenge is that, well, all these countries already have systems for a long time. And for example, regarding the sampling design, may your sampling design be adapted or changed? Some said that it was possible on new sites, or that they were planning to launch a new soil monitoring system. So they could aligned their sampling design to that of Lucas, but others noticed, and it's nearly half and half, that if they would change their sampling system, it would make them lose the historical perspective. They would not be able anymore to have historical perspective, and that's the value of soil monitoring systems. So that's not possible. Regarding, for example, the description of soils, some noticed that the translation of national classification into the WRB system can be made, but others mentioned that they needed for that to have skilled people, or that it would require too much time or too much work on the site for the capacities and the budget available so far. So you see, the colleagues went really through a number of questions related to how to harmonize these national systems with the European one. And you see that it is fairly balanced, but there are opportunities to develop. Now, what was decided was to launch, based on this work, the decision between the AJP Soil Consortium and GRC was to launch a collaboration with Lucas to compare with the same approach national data with Lucas data country by country. And you see here 2 graphs for silt content and clay content, but also to develop transfer functions from sampling methods to analytical methods based again on Lucas 2020. And this graph shows you the schematic of what is planned as intercomparison. So for example, on Lucas site, there will be activities to compare analytical methods. So Lucas samplers will do a double sample that will be analyzed at EU and in different national labs. Sampling protocols will be compared on Lucas site with national samplers going with the Lucas samplers, so that the 2 operations will be performed. On national sites, again, analytical methods will be sampled, and one sent to EU and to GRC and one to national labs. Sampling protocols, again, will be compared. And there's also a study undertaken on an uncertainty analysis on national sites. So an exciting work that has started this year, that is starting. And our next steps are to publish our first results, of course, to compare the results of the datasets comparison country to country and at the European scale also, assembling all the national data, to organize the collaboration. Well, still are in the process of organizing the collaboration because between Lucas 2022 and national sampling campaigns, so what I just presented you. And we, of course, want to continue to collaborate with GRC within the framework of AJP Soil, but also within the USO working groups. And a number of our colleagues have are participating to USO working groups. Before I stop, I would like to summarize what we see as benefits and drawbacks for a country-driven approach. And this is meant to really to promote discussion. What we see is that national information, so either maps, monitoring, is authoritative, and it is therefore used in the application of national soil protection policies, and sometimes with quite a history already. This national soil information well suits the national needs and the specifics on soils, land uses, and climate. It is often more detailed. However, the diversity of these national systems, as we have extensively described, makes information exchange across borders and assessments, EU or multinational scale assessments of the implications and the evaluation of EU policy really difficult. Of course, everyone knows that the EU Lucas soil monitoring system started because data sharing was difficult 20 years ago, while there was already an identified need for harmonized soil data in Europe. But where we are positive is that we think we have entered the information age And now exchange of information becomes technically possible. Harmonization becomes technically possible. And this will allow better information at the EU level and better informed policy, transboundary research. It's possible to have efficient and coordinated action between different national soil monitoring systems. And we would like, of course, to remind that AJP Soil is a technical project. We are very enthusiastic. We want to continue. And but of course, we are not, decision to cooperate is for member states at policy level. So we really wish to inform the different countries of the work we're doing. And for example, in the AJP Soil, we have national hubs in each country who are groups of stakeholders that have been selected by our program owners. And our intention this year is to focus on soil data and present them the results of our activities, is basically what I presented you, but also soil data sharing to make, yes, to improve their, so that they will be better informed of the situation and yes, can take steps into multinational or European scale cooperation. And on that, I would like to thank you for your attention.
Thank you, Claire, for this consequent work, which is very interesting and it's quite challenging. But you are on a good running process. I'm looking at the questions in the chat, and there are some questions for Arwin. First question from Isabelle Fex. In what, and it's related to the concept of the minimum detectable difference, to be able to see how much time is needed to detect the difference between a time one in the monitoring and a second resampling phase. So in what temporal interval do you think Lucas Soil will be able to observe changes in trace elements levels in soils? Arwin.
Yeah. So it's a good question. Actually, I had started to write the answer in the chat, so I've caught up in me. I mean, so in Lucas, we've only really done a comprehensive analysis of certain metals in the first survey, 2009, 2012, and in the 2018 survey, we reanalyzed, let's say, a subset of those significant samples to see if they were still present in the soil, and they are. And let's say within we don't see major statistical differences between them, which makes us think that possibly they are linked to background values potentially reflecting geology, but we're still carrying out some more detailed work on that. We've never sampled, let's say, some of the other, let's say, micronutrients, for example. That's something that we can think about doing on the analysis, on the samples collected in 2022. But in terms of time frame, I don't know. I mean, I think it reflects probably the use of the soil. Maybe if it's subject to things like sewage sludge applications, but I can't really give a comprehensive answer to that at the moment.
A question also from maybe for Claire. It's from myself. So I was wondering, what do you consider as a monitoring site or scheme in the EJP Soil project?
I will leave Antonio to answer.
Thank you, Claire. In fact, you're right, Esther, because we didn't put a definition and we had very different answers because few countries consider that, let's say, they have monitoring sites. They were monitoring, as it was just mentioned by Arwin, few countries are monitoring the effect of sewage sludge disposal on field, and they declare that as a monitoring system. And we had in mind a national monitoring system, and not monitoring sites where you are looking at special threats, for example, or a different issue. So our definition, we didn't put the definition thinking it was clear. And in fact, it's not so clear that for us, a monitoring system it's something at national level that should be able to report on the threats, on soil threats, on soil quality in a long-term frame. And it was not so clear for all the countries. So we didn't put a definition, and so it's you're right. We need to define that for Claire presented at the end that we should publish the results, and so we should be very clear on what we consider a monitoring system.
Yeah, thank you. It's always a question of terminology somehow with soils. Another question for Arwin on the biodiversity indicators for Lucas soil. Is the season of sampling independent? And what about if some samples are sampled in winter and other in spring, for example?
So the entire Lucas soil is carried out set between April and September. So we are talking predominantly about the spring and summer, so we don't collect any samples in winter. We have tracked, so we have the date of the sampling, so we can see when the sample was collected, and we're actually carrying out some work now to look at weather conditions preceding the sampling, because maybe you don't recall, but in 2018, when we took the first biodiversity samples, half of Europe was underwater and the other half of Europe was cooking. And it'd be interesting to see whether we can see any links to those weather conditions at the time. But indeed, yes, it's clear that there will be temporal dynamics to the biodiversity information.
Yeah, it's always the difficulty to interpret such kind of parameter, of course, through time. Maybe I see the time running. A last question, maybe with a short answer to Claire. Is it planned to develop? No, that was not that one. It's a question from Togola. What about pollutants measurement in soils, in EGP soil, but also in Lucas initiative?
Well, in the survey made by AJP Soil, several countries do measure contaminants, pollutants, but especially trace metals, but I do not know how many, I heard. But again, Antonio will be able to complement.
More than 50% are measuring trace elements, but it's very less for organic contaminants. It's around 20 to 30% that are measuring organic contaminants. But for trace elements, it's more or less more than 50% and near to 60 to 70% of the countries are measuring trace elements.
I guess this will be detailed in the publication you will provide. And Arwin, I think you mentioned that you were targeting metallic trace element. Maybe could you tell us which ones?
Well, that is, let's say, the standard set that are labeled as heavy metals, let's say, in the literature. We also are doing some work on residues of active ingredients from pesticides in soils, and also, let's say, a test on antimicrobial resistant genes, and also on the residues of antibiotics, although the antibiotics so far it doesn't seem to be working because we were not detecting anything, and the pesticides work is ongoing, but it should be finished later this year.
Okay, thank you. Yeah.
So maybe one thing to add, that in the Zero Pollution Action Plan communication, there was a statement there on to investigate the possibility of using the Lucas as have a pollution module within Lucas. So that's still to be discussed. But one concept being floated is that a bit like the Water Framework Directive. One could consider using Lucas as a sort of watch list, where let's say it could be used to screen the presence of certain sort of emerging pollutants, or where we don't really have a good handle on their geographic distribution throughout Europe, and which would then in itself maybe trigger some further action by member states, potentially, something like that.
Okay, thank you for this interesting reflection. I see that there are other questions in the chat. I invite the speaker maybe to answer directly in the chat so that we can continue our program now. Because we are heading for the second part where we are going to zoom in soil monitoring schemes of some countries. And the first one is from France. So Antonio, please go ahead for your presentation.
Do you see my screen? Yeah.
Not yet.
Oh, sorry. Is it okay?
Yes.
Yes.
Okay, fine. So thank you for inviting me to present the French soil quality monitoring network that we call RMQS. And I will show you that it's a dedicated tool now to evaluate and monitor long-term French soil quality. So first, I want to introduce the fact that this soil monitoring network was developed within the GISSOL. It's a scientific interest group on soils, and it was created 20 years ago now. And it's agriculture and environment, the two national agencies on environment and biodiversity, and 4 research institutes. And the main aims of the GISSOL is to survey and monitor French soils, to organize and store soil samples and soil information, and then to give access to soil information to the public, and also to support public policies. And the INRAE unit InfoSol acts as a national coordinator for the survey and monitoring programs, and with the financial support of all the. And so I will focus now on the RMQS, the systematic network for monitoring soils in France. We have more than 2,000 sites, and those sites are located along a grid, a 16 to 16 kilometer grid. So it's an unbiased sampling scheme. Claire showed you that in Europe you have different systems, different schemes based on representative sites or on a grid. So the French monitoring network is based on grid, and so it's a for French soil diversity and also the different land uses in France. And we plan to resample the overall network every 12 to 15 years. So we are covering France, mainland France, but also overseas territories, French overseas territories. So the main goals of the network are to develop national statistics, so to be able to report on soil and on the status and the quality of soils, also to map the soil parameters, and we hope also to map soil indicators, ecosystem services in the future. So to get an instant picture of soil quality and detect gradients. We also want to, the network was also think to be a network that can detect the evolution of soil quality. It was also developed for research, for example, to explore the relationships between soil quality and possible controlling factors, and also to validate spatial predictions or to use for modeling. And the last goal was to archive soils and have a bank of soil samples. So just to show you the way we are representative of French soils and land uses, just in yellow the crops, in dark green, let's say forests, and in green, in more clear green the pastures. You also natural land uses, and also the vineyards, for example, I can show you. And you also have the different spots in French Guyana, for example, or in Guadeloupe, Martinique, Mayotte, and La Réunion. So we deal with a lot of different land uses. So we now have two campaigns. The first campaign in mainland France occurred between, let's say, 2000 and 2010. So it's the first campaign that we call RMQS1. And the second campaign starts a few years ago, and we are still running this second campaign. And so for the overseas territories, you have the different dates when we set those territories. And we are now planning a new campaign, the new campaign for the overseas territories. So between the two campaigns, we change our sampling strategy. As you can see, for the first campaign that we call RMQS1, the sampling was done more or less according to regions. And now what we did, we sample on each region around let's say less than 200 samples a year. And so you have we sample each year all the regions with a number of sites on each region. So the idea is to have each year around 200 new samples coming in database, and so to give a better picture of the soil quality. So the idea to do that is to improve the capacity of the network to detect soil evolution, and so to have an information not only at regional scale, but directly at national scale. So quickly, the sampling area on each of those sites, we have a 20 to 20 meters sampling area that we divide in different areas to be sampled. So we collect on each square different composite samples. We mix the different sampling from each cell. So we have 4 samples, 0 to 30, 30 to 50, 50 to 75, and 75 to 1 meter when it's possible. So that was for the first campaign, and then we move each campaign. We will move the different squares, so to avoid sampling again on the same area for each campaign. We also open the soil pit to describe the soil and to sample the soil and to sample the soil for bulk density. So we describe the soil pit, and we also on the soil pit collect samples to make the bulk density. One thing that is also very important for us is to record management practices on the sites, and we will also describe the environment to identify possible sources of contamination. So that's very also important, not also to collect soil, but also to register what is around the site and what are the management practices. And we developed a handbook to standardize the sampling operations, and we translated it, so it's now available in English. You have the link in French, but it will be available also in English. And finally, all the samples arrive at the same lab in Orléans, and where we prepare the soil, and then the soil is prepared on the analysis at the same site. It's in Orléans, and then also the soil is stored here in Orléans. So we have the bank, the archives is in our lab in Orléans. Analytical parameters. So we changed between the two campaigns. For the first campaign, we did let's say the classical pedological parameters, and we also include the organic and persistent pollutants and also trace elements. We also did biodiversity measurements, and also we analyze the quality of organic matter. And for the second campaign, we decided not to measure trace elements, for example, or organic contaminants, as we thought that due to the time frame, and as we are measuring, let's say, diffuse pollution, diffuse contamination, we may see nothing in just 50 to with 15 years. It was quite, well, we thought it was useless to remeasure trace elements. So on that new campaign, we focus on organic matter, on different forms of organic matter. We also measure pedological parameters, and we tested different possible new parameters to be added on the network. Pesticides, soil biodiversity, we are microplastics, and we are thinking about antibiotics. So we already tested pesticides and soil biodiversity measurements, and also microplastics. So a few results from the, you have a map from the carbon stocks, and also map from microbial biomass in soils. So those data are used for IPCC reporting, for example, or also for biodiversity reporting for France. Results also for lead content in soil, and or linden content in soil also. So those data are now used in France to detect soil contamination. And we also publish the results on different databases or websites. And we also produce sites where you can explore the results. So you will have the links, I suppose, so you will have the different slides. So also, as it was just said by Arwin and also by Claire, we are now collaborating with Lucas Soil Campaign. And so as you can see, I'll just show you quickly the sampling protocol, and you see that the sampling protocols and the densities of sampling are also different between Lucas and RMQS. So the idea is now how to compare our results, or to use both results, both analyses, to be able to report on soil quality. So we are now within EGP Soil comparing the analytical methods, comparing the sampling protocols. We also compare the data sets, and we will try to make exercise. So the main lessons, well, in fact, this monitoring network is a huge success because the data and the samples are now used for all kinds of projects and policies. At the beginning, we never thought it will be used like that. So it's a huge success. A lot of people are asking for the data and asking for the samples. And the sampling protocols also must be robust and documented to detect soil evolutions. We think the soil use and soil management activities are needed and need to be recorded to then interpret and model the soil evolutions. And of course, archiving is also a way to develop and perform new analysis in the future. So thank you for your attention.
Yes, thank you very much, Antonio. It's really nice to hear that you also make that the data also come in use, and that you have such an ambitious program. We have one question here from Esther. Can you give an idea of the costs of the RMQS? Do you intend to include urban areas in the future?
Well, the RMQS, it's about €1 million each year, and it's more or less half public budget, meaning that it's the salaries of INRAE, and the other half it's the money coming from the funders. So it's around 500 to 600 kilo euros each year that we have to fund, but it's within the GSOL, and it's funded by the ministries and the agencies. But of course, if you include new parameters like soil biodiversity or soil pesticides, then the costs will, from our first calculations, we think that the costs will double if you include the soil pesticides and also biodiversity. So for the moment, it's more or less around 600 kilo euros each year. But of course, if you add new parameters and expensive ones like biodiversity or or pesticide measurements, then it will double certainly the cost of the monitoring network. And concerning urban sites, in fact, we have already we have, I think, 6 sites that are urban, that are parks in cities, but it's not dedicated to urban directly. But when you do that grid, in fact, you have 6 cities in that grid coming again. So, but it's only 6 sites.
Thank you very much. I'm sure there will be many more questions in the discussion later on, but I think we will have to move on for now. So thank you very much. And we'll move on to listening to the Dutch soil monitoring system. And please, Fanny van Egmond, will you make your presentations?
Can you see my slides?
Yes, perfectly well. Thank you.
Just see if I can manage to see as much as I can as well. So I've been asked to present on the Dutch soil monitoring system, and I'm doing this really on behalf of my colleagues. One of them is also present here in the meeting, so if there's very technical questions, I will give back to him because he was much more involved in the nitty-gritty of the work. Just to start off with, we started soil monitoring of agricultural soils around 1998 in the Netherlands. There have been some trials before from 1988 to get a good impression of the soils of the Netherlands in a monitoring network instead of a static soil mapping. But basically, the aim was to better describe the map units that we have on the soil class map of the Netherlands, 1 in 50,000, and also to determine the accuracy. So there was 1,392 locations were selected. These are the black dots on the map on the right. And this was done mainly, through stratified simple random sampling. And the aim was to also derive averages and standard deviations to get an idea of these strata. And they were based on groundwater depth regimes. So we have a classification system for groundwater behavior in the Netherlands. So it was based on that, and then also on soil types. To get really a good geographical and soil and hydrological typology across the country. It was also sampled according to horizons at that time, multiple depths, therefore a range of soil properties. But we derived, for instance, for bulk density, we use Peter transfer functions to derive the bulk density from texture measurements that we did before. And this data set has been collected in 1998 and has been used subsequently also for LULUCF reporting. So then also a land use characterization was put on top, or this was reclassified according to the LULUCF classes. Then for a while, we did not have specific monitoring of the properties of Dutch soils until 2018 basically, and then we did a monitoring campaign that was mostly focused on carbon. So we looked at what data sets do we have already that could be a nice comparison, and we came to the LSK data set that I just presented. So we decided to revisit those points and change a few things in the design. So we decided to use the Lucas sampling protocol as explained this morning already by Arwin. We did a couple of changes where we replaced the spade with an auger, a soil auger. We added a per meter logger to measure penetration resistance that goes to soil compaction. And we also decided to do a measurement of bulk density instead of the Peter transfer functions with a soil auger. And the reason to use the auger instead of the rings is that we had to move very fast. This was, we had 3 months to sample everything and all those points, and also preparation time was relatively short. Unfortunately, also due to the dry summer, some of the results were not that reliable, but at least we have some measurements. We also changed to layer sampling, so that better coincides with Lucas, but also was made from a practical, that choice was made from a practical point of view, because we didn't have soil scientists, but soil samplers going into the field. And the aim was really to determine the differences in carbon over the last 20 years, and to also have a baseline measurement for monitoring in the future. So the basic principle would be that if we have this as a new baseline with some changes compared to the last one in 1998, then we can also subsequently in the next 5 years to come, every time do a new monitoring and establish this as a monitoring network. We measured quite some soil parameters. This is a selection that I list here on the sheet. There's been more parameters measured, and we also did some comparison with how does this monitoring network compare to other national monitoring networks, and it's largely comparable with Belgium and Denmark. So I'm really looking forward also to the presentation from Esther later on to see if this actually also holds up for Wallonia. Some pictures as an illustration. So this is the sampling protocol. On the top left, you see I don't know if you can see my mouse, but this is the soil auger that then we use for also bulk density measurement, the per-meter logger for penetration resistance, and the Lucas way of sampling. We trained all the soil samplers to get an as homogeneous application of the protocol as possible. And we ran into a couple of challenges that you get when you have a monitoring network that you revisit 20 years later, because it turned out that quite some locations could not be sampled anymore, because either there was a house or some infrastructure built on top, or it was converted to water or nature areas. So that was challenging, or access was not granted. And these are some examples of where we could sample. So that's both in nature areas, forests, grasslands, and croplands. We did not make an extensive soil profile description, but we did take pictures of all the soil profiles and also of the surrounding areas. So in that sense, we do have some information on this. And obviously all the samples were processed in the lab, dried, and subsequently analyzed. And this is just to give an impression of how many points we could not visit anymore. So what was the change in 20 years time? So on the left, you see all the sites that we still could visit, so that have been sampled, and on the right, all the sites that were not possible anymore because of land use changes, because of a lack of permission to access the field or the location in question. So it's about 85% of the sites we could visit again, and 15% was no longer available. Just some results. These are maps of the carbon stocks in 2018. On the left of the lower layer that we sampled, so 30 to 100 centimeters, and on the right of more of the topsoil, so 0 to 30. And we did quite some calculations also to understand how the soil organic matter, soil organic carbon content and stocks changes in the last 20 years. These are the numbers for soil organic matter contents, where you see that especially in the deeper layer, we see a significant decrease in soil organic matter content in the last 20 years. We did also some calculations for soil organic carbon stock and some additional measurements to see, okay, how does this, can we derive soil organic carbon from soil organic matter, and is that influenced by anything? And we found that actually that conversion factor that's usually 0.5, it depends on the pH, on texture, on aluminum content, and can therefore vary quite a bit. And also because we do not have the soil bulk density measurements in 1998, we do have stock calculations as well, but they are a little bit less certain than the soil organic matter content measurements, because these are actually measurements. So we would advise in future to monitor soil organic matter, carbon, and also the nitrogen and the sulfur total concentrations. Upon realizing that we could not visit all locations, we also had a look at how many points would we need to accurately assess whether or not the amount of soil organic carbon or soil organic matter has changed in these different domains in time. So this also compares a little bit to what Arwen was presenting for Lucas. And what we found is that in general, so for all the mineral soils, or for all the soils in the Netherlands, this is the picture of agriculture mineral. These are some translations from Dutch. That we would need, this was our current amount, and we would need more samples to be able to accurately assess whether or not there was a change. And if you then would like to subdivide that into further strata, so Akkerland is cropland, and these are different soil types or texture classes, so clay, loam, rich in organic matter, and peat and sand. You would need to take quite a lot more samples or observations to be able to assess that difference here in the black line. And for very high organic matter rich soils, you would really need to go to an enormous amount of samples to be able to assess the difference. And this is the same graph for grassland. So this gave us an idea of, okay, if we want to know more about the changes in those strata, how many samples do we need to take? So this is the result of that analysis. We started off with 1,300 locations in 1998. Of those, 1,100 more or less were still available in 2018. If you like to compensate for that, you would need to add the missing 200. If you would like to prepare for that in the future, so knowing that some sites will change, you would need to add another amount of samples. And if you would like to be able to say something about the differences in soil organic carbon or soil organic matter changes until 2030, for instance, you would need to add 800 samples in total. So you would end up with about 2,000 sites, but that only gives you information about the change in carbon or organic matter stock in mineral soils under cropland or agriculture in the Netherlands. So this does not allow for further stratification. But well, it does give a good idea of where you should add points in which strata to get to which conclusions. And this is not so monitoring, but I very briefly wanted to mention that we also have a little bit more static or continuous soil analysis and soil mapping in the Netherlands, where all of these classes that I listed on this slide are generally available. It's open data, accessible through the portals here on the left bottom to everyone who wants to use it, basically. So this is additional to the soil monitoring processes that I just described. And this is just some pictures. So everything is collected through a field GIS system, and later on also mapped and made available online. Now to just briefly see, okay, how can we or where do we want to link up with the work in EGP, and what do we consider useful for the Netherlands? And that is so I copied actually these lines from Claire's presentation. So we will compare the data sets. What does the Netherlands report about the Netherlands, and what does Lucas report about the Netherlands when it comes to soil properties? We will develop transfer functions to the extent possible budget allowing also for the lab methods. So how does the Dutch soil lab compare to the Lucas soil lab? Can you make transfer functions for that? And also how to combine sampling designs, because we took a different approach than Lucas. Can we somehow use that data together to get to more detailed estimates of averages or increase or decrease or constant value of soil organic matter, soil organic carbon, and maybe other soil properties in time per strata? So can you then differentiate maybe? And we will take advantage of the Lucas 2022 campaign to try to do that. And just some pictures. So these are the locations that we sampled in 2018. These are the Lucas points in the Netherlands in 2018. And this will be the combined map where you see that some areas that have been less sampled, for instance, this area here in the Dutch campaign, actually have some Lucas points, which is really nice, which would really contribute to the data. So we see this as something that is interesting to investigate whether or not it is possible. Briefly to mention that we are also taking part in some other projects within the scope of VGP soils that are really aimed at innovation of methods. So can we be more efficient or more more fast, basically, to acquire soil property data? There's 3 projects that aim for this: Sensres, Steropes, and Probefield, and they're looking at ways if you can use remote or proximal sensing methods to improve it in such a way that it can be a useful tool either for farmers or for regional authorities or for national authorities to acquire more or more detailed soil data that then you could at some point maybe also add to these data sets that we're acquiring at national level. So basically, there's a couple of technical questions that we have as an institute at the moment and that we would like to figure out and that I think are relevant also for this group. A question that we have is, should we synchronize with Lucas or asynchronize? So should we try to do the Dutch soil monitoring in the same year as Lucas or in the years in between? So does it lead to better detail in space, for instance, in more strata or in time? A general question for any monitoring system is, what will the data be used for in the future? And with that in mind, is it then still fit for purpose, or do we need to make changes either in density or in a temporal dimension, land use type or land use change, soil types, different parameters? Will the data be used for indicator calculations later on? Another question that we have is, what will be the legal implications of sharing data within all the new directives and laws that Arwin showed? And for us as executors of this soil monitoring system, basically the question is, okay, how does this also influence consent for data collection and or data sharing? So can we still have access to a field if a farmer is afraid that he will pay the consequence of getting his field sample? And also, how to integrate new data sources. So farmer data, citizen science data, regional data, national data, European data, also in light of the new data directives and regulations that are coming out of Europe or that exist at the national level. That was my presentation. Thanks a lot.
Thank you very much. That's a really nice presentation. I think we will have time for one comment or a question. I don't see really a question, but a comment from Esther, and it's on the interpretation, well, the issue of land use change for interpretation of the change in SOC. Maybe Esther, since it was a long comment there, could you maybe explain yourself, your comment?
It's just to, I fully agree with the issue of land use change in monitoring sites when they are not controlled and stabilized through time with the agreement of the owner. We we faced the same issue when we did an exercise for carbon content change when we resampled the sites done for the soil map back in the 50s of the last century. And part of them were of course not usable anymore. But what we have seen is that from the exercise of resampling those sites and using the soil routine analysis made by the farmers and that are asking the analysis on the public laboratories. And as we can have an access to those data, given some conditions and respect for privacy, then we could see that it was not so much a difference between the results from the really resampling exercise and the one from the geoprocessing of many data on the agricultural land. So somehow this can be adjusted somehow, but the problem is then the interpretation behind, because of course when you get land use change from grassland to cropland, then you get lots of organic carbon content. So it's the question of interpretation, not so much the status, but more the interpretation of data, which is challenging. It was just a comment, but I have many similar questions that you raised in your presentation.
Yes. Okay, so thank you, Fanny, and we'll actually move on to Esther. So maybe you can raise your questions now in your presentation, because you're going to tell us about the balloons soil monitoring scheme now.
Do you see my screen?
Yes.
Okay. So digging into what we are doing in Wallonia on soil monitoring schemes, and you'll see that I took monitoring schemes a bit wider that you took in the previous presentation, and it's partly linked to the question of what is a monitoring scheme actually. I first dig into consideration of soil and land data and what they are used for, then presenting some monitoring schemes available in Wallonia, and then focus on some thematic examples that were proposed for today's discussions, and have some conclusion. So soil and land data. So what we should be kind of focusing on is the proposal from coming from the soil strategy, where you can see that the soil health is defined as soil being at good condition in chemical, biological, and physical ways. And this allows for providing many ecosystem services. So the issue there is really to get data on those three levels, chemical, physical, and biological. And that was nicely presented by Antonio and Fene. Of course, those are quite classical parameters, but still really needed. You can get them by soil sampling, but also by remote sensing for some of them. And this is really developing quite fast. So a combination of both is really ideal. In Wallonia, we kind of get all those data available, but with a real unequal spatial and temporal coverage. So you will see it in the further slides. But on the availability of the data, generally we try to put them in our geoportal, which is driven by the Inspire directive, and you get all the data there to be able to use them, to download them, and to visit them. I really recommend you to go there, except it's in French, but still. Of course, for some specific applications, we have other websites. I will give you one example later on. And also some data are still need a request to the data owner, as they are not publicly available. We use those data, as it was mentioned also from a previous speaker, mainly for indicators. We have like a state of the environmental report in Wallonia since 1993. And soil has always been part of those reports since the beginning, starting from soil types, of course, and general pressure and management, but then adding on specific thematics, and I put them in bold through time. So local pollution came more specific in 2003, together with acidifying substances and metallic trace elements. Also the critical load in forest in nitrogen. And then after, water erosion came on, and it's those topics came on because of research projects mainly. And then after, soil organic carbon, which was also increasing in the discussion. In 2006 and 2007, we had additional consideration on soil fertility, biodiversity, also diffuse pollution, soil sealing and soil compaction. And this was, of course, linked to the discussion of the previous soil strategy back then. Then it went on with additional topics, including phosphorus issues, also risk areas for diffuse erosion, also some discussion about the capacity of agricultural soils to receive metallic trace element. And then also later on, soil biodiversity in 2017 is coming in the discussion. Also, we are still looking for some indicators. Ecosystem services also came into the environmental report in 2017, and now you can find online all the different indicators with regular update, and you can see the date of the last update in here in the slide, with the last one being local pollution. Also, just for information, there was also a big work on trying to raise awareness on environment, and one of the 10 topics was soil, so it's also available online if you are interested. But then, what are the sources of data in Wallonia? The first and main one actually was the big effort made in the 50s last century to build a soil map in Belgium with a resolution of 1 to 20,000 and with 1 to 2.5 observation per hectare, which is quite dense. It led to about 15,000 georeference soil profiles. So that was a very clever thing to georeference them, because now we can use them as resampling exercise for some of them. Mainly the physical chemical parameters were analyzed, not so much biological, but really it was a very strong commitment with focus then on natural, agricultural and forest areas, not on urban soils. It's quite exceptional at that time. It entailed quite high costs. I didn't get the cost, but it was quite high. As I said, no direct biological parameters, and it's unlikely to be redone another time. But what we can do now is to resample some sites, and it was done for the issue of organic carbon content and stock. So from there, what would be next source of data, which are more recent? Well, we had for a classical forest network survey, like was presented for France in RMQS or in Dutchland. This one is for forest. We didn't do one for agricultural soils. The one from forest is running from 1994. 11,000 sampling units, and 10% of the sampling units are revisited each year. It's not focused on soil, but it's including soil parameter, quite basic ones, physical chemical ones. And it's actually anchored in the forest code regulation. So it's a legally based monitoring, which defines how much human resources is dedicated to it. There is also a scientific support, and of course it entails cost, and it's way wider than soil. But one option is to quite improve what is currently done for soil parameters. Moving from such classical network, we go also for remote sensing monitoring, because yes, of course, satellite images, LIDAR, flights and other technologies can reveal lots of interesting information, essentially to do thematic maps. linked to topography, land use, and DVI, organic carbon content as well. Either you get regularly available data coming from the different institutions, or either coming from punctual assessment, and this is done for through some research project. Mentioning the word soil, which was also mentioned by Arwin earlier on. It's such kind of data really driven by a dedicated research project or availability from other institutions. The costs can vary depending on the level of details and resolution. You still always need validation with field samples. That's always needed. And it's especially focusing on land surface and not so much on soil, at least the parameters are quite limited, but still this information is very useful for modeling processes linked to soil dynamics. So this is one important source of data in Wallonia. Other source of data, and you see that my understanding of monitoring is quite large, is from the legal obligations that can be put in the text, and especially on soil investigations and land management processes. You can see here that we get data on soil and land from old legislation like waste legislation, environmental permits, or land planning. Those are quite mainly indirect data, but still very interesting data to go for management of such problem. Then you get data also from sewage sludge directive transposition, and this is very useful to, for example, establish background concentration level in agricultural land. Get also data from air and water protection, which are more indirect data, but still for diffuse pollution, this is very nice source of information. We can also have more indirect data from the agricultural legislation, because there is no mandatory soil sampling now, but still lots of ancillary information useful for example, soil erosion modeling. And last legislation really then targeting soil investigation for local pollution, and also requiring some soil sampling for excavated soils. This kind of data are very useful for such kind of topics. So the problem is then you get different level of digitalization of data. This is hard to put together. It's quite unequally distributed through space and time. But what is interesting is that the cost is borne both by private and public sector, which is not negligible in that time. Another source of data that we are using more and more are the soil routine analysis made by the public laboratories of the network called REQUA-Sud. There is one per province of Wallonia, and they have georeferenced their sampling since 2005, which is a very useful information. Of course, you get issue of confidentiality, but as long as they keep the X and Y data and that they provide us, I would say, maps with overall geoprocessing treatment, it's in line with our GDPR. We can get then from there some basic soil fertility maps for agricultural soils, and you have here the website where you can consult it, and it's made by municipalities. And also more and more we use such data for the soil and plant transfer issue of pollutants, and they have data on vegetable gardens, so it's becoming a bit wider than just agricultural soils. And it was used for the Sunny Soil project. The advantage is to have thousands of data, we used 44,000 data for organic carbon content, but then you need quite specialized geoprocessing procedures. The cost is shared somehow with the private sector, and somehow the soil sampling can be funded if needed. And if you get the right procedure in place, it's very easy to update such database. Another usual way to get data is from research projects, but it's rather thematic maps. And here you can see some of the thematics that were, of course, investigated in Wallonia. It's classical data aligned with the soil strategy and the soil degradation topics, but it stays punctual assessment, although very highly skilled assessment with good data quality, especially the quantification of uncertainties is available, but also of course the cost is borne by public sector usually. But it helps to improve our knowledge through time on specific topics around soil. And last but not least, well, the initiative of trying to complement national or regional data with the European soil surveys. This current exercise for 2022 is under development. The advantage is to have regular assessments of such exercise. There is always the issue of data quality and local authority involvement, but as Claire said, I think we are entering another period for collaboration on those points, and the costs are still borne by public sector. So what we are heading for in Wallonia, actually, we try to combine those different approaches to optimize the cost and the data. So we rely on legal commitments, and there are some systematic monitoring already for forest. Not sure that we will have one for other land uses, but that could be maybe envisaged if the discussion at the European level are strongly heading for that situation. But what we use is really triggers for soil investigation with reporting obligation, and this allows to be based on private funding mainly. So now triggers are already existing for local soil pollution, but that could maybe be envisaged for other type of soil degradation. The issue there is to be able to use those different various databases and to structure them, and that is very challenging. Public funding is always a mean of getting data information, not only for research projects, but also to collaborate with laboratories, running with routine analysis. That is really a key that we are investing in. And also funding land managers to better get to improve their knowledge on soil quality. And the initiative of test your soil for free would be in line with that part of the public funding. We have right now a recovery plan for Wallonia with important budget associated, and we identified some soil actions along with that public funding of soil quality assessment. And I think we will rely on joint monitoring action with institutions such as Lucas. For Wallonia, the density of sampling point provided is quite interesting. It's about the same that we used for the network for soil organic carbon. So I think it's a good sampling density. And as many parameters will be done by the Lucas campaign, I guess we will use it as a monitoring input for Walloon discussions. And the step towards the indicator for soil quality is a quite difficult one, because you've seen the different parameters, physical, chemical, and biological, but how to get to like a soil quality index. There was some initiative in Brussels to do it with weighting parameters between parameters. We will try to get some reflection on that one, because it's somehow one of the only way to really facilitate decision-making process for non-soil experts. So we need to digest all those parameters to be able to better protect soil when land management decisions are taken. Some just thematic examples here for carbon storage. You can see on the left, and it's available directly in our geoportal, that we have some information for soil content in agricultural soils already then in the 50s of last century. Then we had one resampling exercise of some of the places in between 2004 and 2014. And we had another exercise between 2015 and 2019. Why this period is because it's taking quite time to revisit the places, but also by using soil routine analysis, we need to get a good coverage representation. So we need to have a period not focused on 1 year, but on a range of year, a small range of year. From there, we get the differences, and here you can get the differences between the last period and the period between 2004 and 2014. You can see that in green it's quite stable, but still we get a decrease even within that short period of time at some places in Wallonia. We also get uncertainties. This is coming from then the combination of the Belgian soil map research project and soil routine analysis. And for the stocks, we got the bulk density for the period of 2005 and 2014. And we used the pedo transfer function for estimating other the stocks for other periods. So the pedo transfer function discussion in the EGP soil will be of interest for that. Water regulation, we get map of diffuse water erosion risk. It is not really used as a legal commitment, but it's really useful in many land management decisions. The runoff axis, which is called LIDAX in our terminology, is used, on the contrary, on a legal basis. And when you deliver permits for urbanization, then you need to consult that layer and take it into account. On the topic of soil pollution, for the point source pollution, we got a soil status database, which is called BDES, and we get a special application for it. But basically, you get ID at the cadastral parcel level of the situation and the level of information we have on that site. For diffuse pollution, there was a research project, CAPASOL, and that integrated previous research project as well, such as Pollusol, and we get good levels of, let's say, background levels for different heavy metals that you can see here. And we can use the forest monitoring network for that as well. This is just focus on the local pollution. This is the application where you can find more information than on the geoportal. You can see that there is two colors, one peach color for giving information on soil investigation made by experts and based on the soil decree and previous legal basis. You can also find environmental permits with potentially polluting activities, and also other information where there is an accident or for pollution, local pollution. In a blue color, it's more historical information. We exploited data from the 18th century already. And you can also get information on backfill location and potentially suspected pollution. When you have transfer of land or transfer of environmental permit, it is mandatory to get an extract of that database in the notary act to make sure that everyone knows what information is available on that parcel. Yes, we have about more than 50,000 parcels in our database currently. Last example, soil sealing, or how to use or to value the soil biodiversity. The soil sealing is mainly linked to land use and land cover. We have maps available in the geoportal based on the resolution, the remote sensing layers, but we need further improvement to be able to get time series and to have quite detailed information. So there is a work on it right now. And for how the question of how to integrate the soil biodiversity in the land decision processes, well, there was a recent map this last summer on the identification of soil ecosystem service for nature and biodiversity. It's based on the soil map, of course, but also digital elevation model and flooding areas, and it identifies the marginal or sensitive ecosystems for biodiversity. It's not yet used in land decision-making process, but I guess it will be it will be the case in the future. On the soil quality indicators, biological ones, there is a start right now of nourishing a database to get referential at the regional level. We don't have maps yet, but we hope to have it in a few years based on 8 main indicators identified in the research project. Some conclusions. So what we are relaying on, it's a combination of various monitoring schemes. So in a wide sense, the classical systematic one, but also punctual soil surveys. And we need to rely on triggers for soil analysis. Legal or not, it is not always needed. And joint action will be really reinforcing the monitoring schemes in Wallonia. We always need to keep in mind that each monitoring scheme has a certain purpose. So the design might be different from one purpose to another one, which is the difficult part of the monitoring issue. There is always the need of political will, because costs are linked and maybe significant. The issue of data quality, the new parameters collection, and the update of all the data are challenging, especially the structuration from various databases. And then key issues around the access to the data and the provision of indicators for soil quality or soil health to allow integration of soil protection in the assessment and decision-making processes. So those would be the main conclusion, and the questions raised by Fene are also very relevant to me. So thank you for listening to me, and just stopping the share. And if you have questions, I'm available.
Thank you, Esther, for a very nice presentation. And there is no straightforward question, but there's a discussion going on in the chat about that new European law might relate to ecosystem services a lot. And have you considered including or developing more indicators for soil ecosystem services? And I think that maybe you can start comment, but then maybe then also, because we're running a bit late, bring that question also into the discussion, which Rita is going to lead in a minute. But maybe you would like to say something to start with.
Actually, when you want to answer a soil ecosystem service like carbon storage, you just go back to classical parameters. So the idea is sort of to ensure that you can get those data coming from different monitoring systems, but then after to translate it to ecosystem services is just a way to present the data to the land manager, actually. And so the issue is not so much the data themselves, but how you combine the parameters to make an indicator and to use it as a good evaluation of your service for that you have mentioned. So for me, I'm not sure that the monitorings currently done in the different countries are so much bad at it, but it's just a question of translating them into the concept of soil ecosystem services. This is how I would comment it, but maybe there are other thoughts in that.
Yeah, maybe to react to you as well, Esther. I think in the Netherlands, for example, it was quite early on in 2007. There was like a small pilot in an area where they actually did look at some sustainable references for some of the indicators we know. And they tried to kind of combine those with the ecosystem services they could provide. And it was quite interesting, but I think they concluded that in the end, it should be more connected to what measures you can then take. And I think that is kind of an area of research which has not really made the connection yet in national monitoring. But I think under the soil strategy will become very important. So just like an addition from the Netherlands, that there has been some research on it, but it should definitely be continued. Fanny, would you like to comment?
Yeah, maybe just to add it, also in the meantime, we've been working on developing indicator sets really based on physical, chemical, biological parameters also for farmers. To help them judge the quality of their soil, and it would be nice if we can also translate the national soil monitoring results to those indicators in time. Within EGP, there's a discussion going on in the chat on the Siren and the Serena project. Maybe Antonio, you can add, but there we also trying to look at how to harmonize indicators for Europe, also towards the answering the EU soil policies.
Well, Claire already commented that the Siren project was a stock take of existing indicators for soil quality and ecosystem services provided by soils in EU countries. So you will find the report. And as it was just said by Claire, there was also a webinar made by given by Jack Faber. And the webinar will be available. And it's a summary. It's a huge report with a lot of information because it was a questionnaire around the countries about if they are using already indicators for soil quality or indicators to report on ecosystem services provided by soils. So the report will be available, I think. And the webinar will also be available. And the other project, Serena, is just starting. It started this year, so we don't have any results. And the idea of Serena is to stock take the existing exercise on ecosystem services in different EU countries, because several countries did investigations at national level to report on different ecosystem services provided by soils. We know that there are existing exercise in the different countries, but we are also collecting such kind of exercise at local or regional scales. And then the idea is to develop a methodology that can be applicable at a regional or national scale, and to ask countries to do that for their countries, but also then to collect such information and to provide maps at EU scale. But we are just starting the work now and stock taking the different exercise that have been done at country level.
Thank you for the application, Antonio. And I think that would definitely be extra information that, at least for me as a policy advisor, would be interesting, looking at also the spatial allocation of functions and how they relate to ecosystem services, which I think is something in the Netherlands, especially as a dense country, we have to think about a lot. And I think is also very relevant for other EU countries. Would anyone else like to add something on this point of moving towards the integration of ecosystem services? Otherwise, I think it would also be interesting to maybe reflect a bit more on the question posed by Fanny and Claire, which I think will be very relevant and is more about the integration of national and Lucas data, and how they could reinforce each other is that indeed more like a spatial or area value, or is there also like another value that they could give to each other? Antonio, you opened your microphone. I'm not sure.
Yeah, but I saw Arwen is also raising his hand, so you raised his hand before me.
No, go ahead. You're on the screen and talking. Go ahead. Feel free.
It's okay. I was just saying that the idea is within EGP Soil we this year will compare the data sets, and we will, as it was said by Fanny, try to think about how to integrate the data. We can, of course, we don't know actually. Well, for France at least, I don't know if it's statistically right to mix the data sets, even if they fill the gaps, because as it was shown by Fanny, we have areas where we have more dense information coming from Lucas, because we have a 16 to 16 grid. So in a few areas in France, I show you the density map of Lucas and the density map for RMQS, and I think we can take benefits from Lucas, because it will fill certain gaps in your data sets, but we don't know exactly if we are allowed to mix the data, because it's maybe we have different methods of course for sampling, but also for analytical procedures also they may be different. So we need to look at that first, and then try to construct transfer functions. It was also in the chat. So the exercise we are conducting this year with Lucas campaign will help us to design the way to collaborate and to mix the data sets. And if we cannot mix the data sets, we can think about other statistical procedures to use both data sets. And because I think the data sets are very complementary. They are not. Using the two will help us to report on soil quality, but actually I don't know if we are allowed to mix the data sets.
Thank you, Antonio. Arwen, would you like to take the floor?
Yes, maybe just stepping back first, if I can, on the question of the ecosystem services. I mean, the current thinking in the soil health law discussions is that soil health is governed by good biological, physical, and chemical condition, and it's this condition then that supplies the ecosystem services. So the logic would be to go back and measure the parameters that govern physical, chemical, and biological condition, then rather than trying to monitor the ecosystem services themselves. So that's maybe just a reflection maybe on some discussions at the moment. So that goes in line a little bit, I think, with what Esther was saying as well. In relation to what Antonio just said, indeed, I think there's a willingness, I sense there's a willingness to come up with, let's say, an integrated soil monitoring system. And I see it clearly, like Antonio says, that we have complementary systems in many countries. In some countries, there is no, let's say, major active ongoing monitoring campaign. So maybe in those areas, Lucas can help provide some data. We've offered to countries to get in touch with the Lucas surveyors to help them collect the samples. So maybe so at least we try to satisfy that possibility as well, that they don't have to invest in collecting the samples, but they can invest in analyzing them. But at the end of the day, I think what we want to be able to do is to find a way to understand whether all these policies that we're furiously developing at the moment have any impact at all, and so we want to be able to show that indeed the carbon stocks are increasing, that the levels of pollutants are decreasing, biodiversity is increasing. So they're quite simple questions that we want to try and answer, and I'm sure that it's not beyond the bounds of possibility to be able to come up with clear answers to these or admittedly, probably over a longer time frame than you see in other environmental monitoring campaigns like air and water. So we have that additional difficulty, I think, for soil. Yeah.
Can I maybe just ask the question to all the policy makers that are present? What is for you more relevant, to have more detail in time or in space? So to know it better per land use type, for instance, or per soil type? Or are you looking for more regular intervals of information on these trends, and then a national level is actually okay?
Maybe if I can have thoughts like on that. I think the issue is to have the right level for the decision-making process. When you have the decision-making process at the regional level, then you need data which are at the regional level. And so the resolution might not be so much of an issue. But when you need to face a land manager, like for organic carbon, he will reflect itself at the partial at his field level. So you need to provide an answer for the field level as well. So that's a combination. You cannot go for one then not doing the other one. Maybe the easiest way is to start from the wider one and then after go and try to improve your resolution, maybe on some critical areas. Because, for example, for soil organic carbon, what we are thinking of is combining the soil routine analysis. It's always available. The update is quite easy, but we know that for interpretation of changes, it will be harder. Then we know that if we see changes in the maps from the soil routine analysis, then it's maybe time to go back to the sampling location and to verify in more detail what has happened actually. So it's, and if you get the factors for changes, then you can go back to the land manager and say, okay, normally this has an impact on the services, the soil service that you are interested in. So you cannot just choose one or the other. You need to do all and to combine the best available information possible. And remote sensing is promising for some of the parameters, but not for all of them. So you always need some soil sampling. That would be my reflection.
Are there any other people that would like to respond to Fanny's question? If so, just open your microphone. I would at least say, Fanny, that I think I agree with Esther. I think there's also like a different value according to time or space. For example, with soil sealing, where also you're kind of both interested, because the spatial element is very important, but also the time element, like how fast are these trends going, to kind of also predict from the data, like what can you change for soil quality, and when do you need to start thinking about this from a policy perspective. So I guess it's not very a complete or desired answer, but yeah.
Well, I mean, from a science point of view, I would love to go to a really great level of detail. So to serve farmers, to serve regional authorities, national, etc. The question is that then the costs mount tremendously. And usually we can't afford that ourselves, and then we are knocking on your doors again. Say, okay, can you please fund this monitoring campaign to be able to provide you with the best information possible? But I do hear also Esther proposing like a tiered approach, where you look, instead of having a general blanket where you say, okay, we do all of these soil parameters on all of these locations at the national level, and maybe divide in substrata for land uses, then we should look at different parameters and see if we can go into more detail in specific locations. That will complicate things, but it's more of an adaptive approach, which could in the end be more efficient. So there's a balance there to be struck, and maybe that's a challenge for us as well, to see how something like that could technically work, and then put some options on the table for you to make a little bit of a judgment call on what would be a good balance between, on the one hand, getting as much information as possible, on the other hand, keeping it affordable.
Thank you, Fanny. Would anyone else like to raise a point? Just waiting and looking around the room, but I don't see any hands yet. And that maybe it might be interesting to focus a little bit on what has been talked about as well in the presentation, which is about the access to soil. And of course, that soil is not like a collective asset, just like water and air maybe. So I'm just interested because Esther, you said some of the monitoring is being taken place on legally based actions. Would that be a road that we would want to move more towards, or is that also quite complicated? Maybe it might be interesting to get some reflections on this question.
Maybe if I was talking about legal triggers, so that means that once you consider, once the political level consider one very important issue, and there should be some soil investigations on some parameters, then you put it in the law and you get it, but you get it not like at once, you get it through time given the trigger mechanism. So the thing is that maybe we should think of trying to get information within a certain amount of time to be able to have a good coverage, special coverage, like Fanny was talking to. So to combine the trigger, the legal trigger, to be able to target the more sensitive areas with a good coverage of land uses, and then also to consider the potential change of parameters, because when there was a question about how much time do we need to detect a change in heavy metals. Well, in the monitoring, it will be quite difficult to detect such changes unless it's a big local pollution. But indeed, we have historical concentration, and maybe we don't need to be and to go back to those places in a short time period. So we should try to distinguish and to have some procedures to really target the parameters that should be followed more regularly and their special coverage, and which one of those parameters should be embedded in a legal trigger, and the other kind of trigger would be like subsidies, and try to encourage people to do soil analysis for some of the parameters linked to soil ecosystem services, for example, and to look for the right combination. And this is the hard part, how to, because we cannot do just one set of monitoring. It's not going to be enough, I think, for what we need. But it's a reflection. I'm curious about how it was discussed in EGP soil, although the EGP soil really focused on classical monitoring and going back to the same sites, resampling sites or such kind of monitoring. But it would be very interesting to have a bigger view of what can be done with different sources of data, and what part of it should be embedded in legal procedure.
Thank you, Esther. Would someone from EGP Soil like to react on that? Was that part of the process of the collaboration? I see Antonio. Thank you.
Yeah, just at the beginning within the work package 6, we collect all kind of data sources, meaning not only the monitoring sources, which we also collect. So we have a lot of databases, of course, coming from monitoring networks, but not only. We also have those databases coming from the soil survey, for example, or soil mapping, or also coming, as you show, Esther, coming from the data collected from laboratories about the soil tests made by the farmers, for example. So we have all those kind of data sources. But the problem with those data sources, when you collect data from different laboratories, for example, is that you do not control the quality of the data, because you do not control the way the sample was sampled, and also the analytical procedures may be very different. So it's more difficult unless you have a lot of data. So it makes a very strong statistical. You will have a strong statistical power because you have a lot of data. But if you have not that much data, then it may be more difficult to make a proper monitoring. We have that in France for the agriculture, and we are only able to detect change at not at local level, but at cantonal level, at municipality level, and it's more difficult to compare the data, because sometimes where the data are not exactly sampled at the same site, etc. So it's more difficult then to monitor the soil quality. It's not impossible, but it's more difficult to, and those data cannot be merged or mixed with other kind of data. So it's, yeah, when you have a monitoring system with the same protocol, the same methods, etc., it's more easy to follow the soil quality. But I agree with you. We need to take benefit of the different sources, and it's not so easy.
Mm-hmm. Yeah, and that really puts the issue of standardization of methods on the table. And that is actually, that should be part of the legal part, because this is the way to control the data quality. We have developed within the soil decree like a referential of standardized methods. Well, it's mainly based on ISO and CN methods. It's not nothing really very new, but sometimes we get more detail we add more details to it. But then the idea is to make sure that any soil sampling follows such kind of rules. And so you need to have that mechanism of rules for sampling. Then after you are more confident with the data quality. Of course, it will never be as qualitative as within a research project when you really control everything. But when you get numerous data, it's okay. It can be handled as long as you have a minimum quality standardization. But I guess that for that discussions in the Glossolan network, which is a world network of laboratories, and there is that regional version at the European level, and the discussions are started. I think this would be very important to maintain that discussion there and to link it with somehow the soil health law project. Otherwise we will go, because the soil law project goes by the results now. Well, it is quite result oriented. And so if we want to say, okay, what is the status of soil within 15 years or in or 10 years, even 2030, we will give some results, but what is the quality of the results? How can we be confident? This is an issue.
Can I maybe also add, I agree with the difficulty of the lab standard. So I think we have a couple of this different aspects to this. So on the one hand, we are looking at soil, which doesn't change that quickly for some of the key parameters that we want to measure. So you need quite high quality data to be able to really prove that there is a change. Otherwise, you can only see a trend maybe over time with quite some noisy data. So there's a matter of accuracy, and that's why we have these soil monitoring networks. That's why Arwin chooses to use one lab. That's why we're setting up these transfer functions and looking into it. I guess we could at some point look at more legal obligations into choosing a lab that has a certain data quality. it could be tricky because you also limit then a free choice. I am really in favor of improving quality through networks such as Glossaland, such as EGP soil, such as other mechanisms. But there's also the aspect then of data standardization. So how do we exchange data? So on the one hand, you want to standardize the lab methods, but you also really want to understand who is collecting what and to be able to share it, to make good comparisons and to add all of these data sources. So if we only are talking about the data that JRC is collecting and the national governments are collecting, then we have maybe about 30 partners. This is a big group, but it's still manageable. If then we add citizen science or farmers data or labs or any other, or companies or NGOs or any other groups that have soil data that is actually relevant, I agree with you that it can help in more detail, in maybe also better targeted at farmers. You want to know for sure that the data that you see is actually the data that you think you see. So there needs to be some standardization and an infrastructure to exchange that data in such a way that you combine it in a sensible way, taking into account accuracies and different lab methods and transfer functions and all of that. And also within EGP soil, and together with JRC, with the EU Soil Observatory, we're also trying to work towards that, to make data standardization easier, to exchange data in a more easy way. And I think this becomes especially relevant with the new EU developments on data policies, or how do you say that? Like the Open Data Directive, data governance, where actually also companies and farmers are encouraged to share their data. It's on a voluntary basis. The governmental organizations have to share their data through Inspire Directive, but also then others are encouraged to share their data. So I think we have quite some work ahead of us, but it's quite relevant. I think we all see the relevance this morning of working towards that. So I just wanted to highlight that there's a couple of more aspects to this, but that they actually are addressed, I think. But I don't know if my colleagues want to add on that as well.
Anyone who would like to add to Fanny's point? I agree, Fanny, on that there are so many sources, and a choice should definitely be made. I think also if you look at, for example, in the Industrial Emissions Directive, I think there will also be some data elements to that regarding companies. So it's sometimes a big forest of which data are we going to gather and which directive. So I think for the terrain of soil, it will be very important to keep a nice overview of that. I'm just going to give the chance maybe to one or two people to raise a point. And then I would also like to go to the message maybe we would like to give from this discussion to the soil expert group. I think we already have some points regarding soil accuracy, standardization, importance of looking at what should be maybe a legal perspective and what should be more on a voluntary base. So I think maybe it will be more practical looking at the Soilver members that we gather some of those points, and that if you would like to add a message, maybe to put it in the chat for now, and then we can gather all those messages and put them in a document, and then we can send it as a kind of conclusion to this meeting from today. So if you would like to add any specific advices, tips, things to look at that we could take to the expert group, please put them in the chat and we will all collect them. And for now, if anyone would like to still raise a last point, I give the opportunity. Arvin, would you like to say something?
Yeah, I think this the point that Fanny raised is really interesting, because indeed, I think we're going to move from, let's say, the traditional concept of soil monitoring, which is someone going out into a field and digging a hole, to an increasingly diverse set of data streams, actually. I mean, ESA are already developing a program to monitor soil carbon through Copernicus systems. The citizen science on soil monitoring is also being developed under the umbrella of the mission. So we will get more data in that way. There's the Test Your Soil for Free initiative also under the soil strategy. So I think we will have to address how to bring together these diverse, let's say, observations on soil and use them in a meaningful way. I think the precision agriculture as well will eventually end up. So I think we're slowly moving to sort of a big data type of environment. And I said the question will be whether we can, what can we meaningfully do with this increasing amount of data, and do these data actually capture the questions that we want to answer? I think that's the challenge. But I think we're moving to a situation where we're likely to be flooded with data rather than maybe the data droughts that we've been seeing maybe over the past couple of decades. Thank you.
Thank you, Arwin. That's also like a bright, positive note to close with. Esther, you have your microphone open. Is it for a reason?
No, I forgot to.
Okay.
to mute.
Then maybe I see some messages already appearing in the chat. So take your time to write something there if you would like to. Ingrid, could you maybe share some of the last slides? Because I would like to go to the closure of today and thank all the presenters of today and the bright discussion in the chat. I think all the information that we gathered will be collected, also what has been said in the chat. And this meeting will be recorded and put on the Soilver website. And maybe it will be an idea that we gather all the messages and we could share them with you if you would like to add in a later moment. Just to give a kind of closure and look forward to what we plan to do as Soilver, as the platform. Just a short recap, that Soilver kind of consists of two pillars, which today we went for the kind of knowledge exchange part, but we also work on knowledge development. Last year we finished some projects regarding microplastics, emerging contaminants, and land use value. And this year we might start another full-scale call, and we're looking for topics to start that call. Then regarding the knowledge exchange, there will probably be some Soilver coffee breaks coming up, so we will inform you on that by email. Some of the ones we're considering are soil health in urban land management, and we'll probably continue these webinars. For now, we talked about soil monitoring, but we'll probably link with some upcoming discussions, such as on soil certificates and the soil passport, which has been announced by the Commission. Yeah, watch out for our updates, and we would like to very much see you soon during some of these knowledge exchanges in the future. And for now, I guess I would like to thank everyone for coming to meet us today. Good to see your faces, and thank you very much. Have a very good week. Bye, everyone.